Good morning, everyone. Almost good afternoon. I will be sharing my screen in just a moment. I know it's not quite time to have everybody join us, but going to give people a couple more minutes, and I'm going to pop up my PowerPoint for everybody. There we go. Give us a couple more minutes before we start. I see people coming in. I hope everybody can hear me okay. Give us a couple more minutes. We have a few more people probably joining us. We have about 4 more minutes to go. So if you need to get up and stretch a little bit, feel free to do that. I'm going to stick to my starting at 11:10. So everybody has a chance to get here. I've got 19 people so far, so it's great. Welcome, everybody. What you're seeing is a picture of a light table. I'm going to talk about light tables towards the end of the presentation and how you can use light tables, how you can make a light table. They're not too expensive to buy, but you can make a light table fairly easily, and how great they are for using for STEM, primarily for as a form of technology. Great, we've got quite a few people still coming in, so I'm excited. Welcome, everyone. As you're waiting for me, I'm going to just wait till it's right at 11:10 to start, but welcome, everyone. Starting to see some comments coming in, so thank you. I hope I'll have time towards the end to respond to that, but I will be giving some more detail on math. Definitely, you'll see lots of math ideas and a lot of use of how technology is woven into math. Hopefully everything is fun and engaging, all the things that I show you. So I hope you'll be able to gather quite a few ideas. I think you will. I see lots of people joining me, so I'm delighted to have so many people show interest in STEM today. It's awesome. It's great. And is everybody able to hear me okay? Just if someone would just say, yes, I can hear you. Great. Thank you. Thank you. Just to make sure everybody can hear me. Okay, I'm going to get started. Oh, thank you for thumbs up. Appreciate it. I'm going to get started because I have a lot of material to cover, lots of slides. I did make my presentation available, and what you will see, I would say 90% of it is what I gave them last week. I do have a few extra slides I added in as I was just going over it late last night, and I thought I'm going to add this, I'm going to add that. So you'll see a few, maybe 4 slides that don't match what you have, but other than that, you have it. I'm going to give you at the very end my email. It's drjeanbarbary@gmail at the very end, and you can shoot me an email if there's something or you wanted this exact PowerPoint. So I'm going to get started. As I said, I'm excuse me, Dr. Jean Barbary. I've been in the field of early education for, oh gosh, over 30 years, doing a variety of different things, from a director of a preschool, program director, college professor for over 20 years. Excuse me, I currently teach for Portland State, and I live in California, and I was a CPIN lead for about 9 years. So I'm very familiar with what comes out of California Department of Ed. I worked for 20 years for the Orange County Department of Ed. So I'm very familiar with all of the programs that come from the state. And I'm very pleased to be here. I've authored 4 books. One is called Baby Steps to STEM that I'm going to present on today. So I'm going to go pretty fast, but I have lots of photos. You'll see lots of it, lots of examples. Just one caveat as I begin to talk, you'll see that we were really focusing on infant toddler, which I consider infant toddler birth through age 3. But all of the information, all of the activities are relevant for our preschool children and our TK. I'm going to start with the foundational pieces. Why is that not moving forward? Now I need to, sorry, there. I'm starting with just the foundational pieces of what STEM is. I'll go into detail, and then I'll move into infant toddler and some preschool STEM activities. So you'll see those as I go along. So what we've noticed is over the years that the United States was originally was one of the top 5 leaders in STEM education, science and technology. And as technology began to really become more advanced, we fell a little bit behind other countries in the world. And so there was a big emphasis on having more STEM activities in college, and more, then it moved down to high school, and we began to see high schools that became technology-based high schools. And then it began to be moved into general education further down. And now we're seeing this emphasis on starting early, starting with infant, toddler, preschool STEM activities, because we know that these activities don't start in high school, that the early learning begins much earlier. So we're really working to prepare our children to be the next leaders in terms of STEM and the importance of STEM, which I'm sure you're very aware of. So we're looking to help children develop critical thinking skills, good communication, collaboration, creativity, and innovative, because we all know how fast and rapid our technology changes. So STEM is science, technology, engineering, and math. Sometimes we'll hear people put STEAM in there, they put the arts in there, which is fine. I'm kind of a purist in terms of my STEM, because I think STEM is used across the curriculum, and I'll be talking about how you weave that through. So you'll see that there's really, when we're talking about, say, science, that you'll always see technology embedded in that. When we're talking about engineering, you'll see science tied into that too. So it's very, these 4 domains are very interwoven in many ways, but I'm going to start breaking that down. So science is a way of thinking. In science, we observe, we ask important questions, we make predictions. We're wondering, we're curious, and this is what we want. We want children to be curious. We make predictions. So I'm going to have you just look real quickly at these little boys. You can see this little boy is pointing down as the other little boy is pouring. So my guess is he's making an estimate. They're trying to figure out how much to pour into each of these cups. They're probably getting water for friends or using it for some activity, but they're making some estimations. They're making some predictions, which is all part of STEM. Technology is a way of doing. Technology uses tools to be innovative, solve problems. Most people will say technology, they immediately think of an iPhone, a smartboard, an iPad, some form of technology. But really, technology has been around since the beginning of time, when man began to think, gosh, how do I lift that really heavy piece of wood up this hill? Or how do I get something down a hill? And they began to think about how to create levers and pulleys, gears, things like that. There was technology has been around. And so I'm going to talk to you a little bit about what technology, further on, I'm going to give you examples of that, but you're going to see me show you as we go through the slides and the photos where technology is, because these are things that are important for you to understand, that technology is not putting that little one in front of a piece of a phone or a tablet, which we see so often these days. So I wanted to start with this, so showing what the NACE, National Association for the Education of Young Children, and the Fred Rogers say about technology. And this is a new slide, so you might want to snap a picture of this and share it with your parents or your colleagues, even family members. So children under the age of age of 2, they recommend that they have no form of technology, no form of technology. And if it is, it's limited to technology that's builds or supports a relationship with children. You might show a photo of the child doing this or that, or a really quick little video of, say, their birthday party or some sort of activity that's STEM related. But for the most part, they recommend no technology before the age of 2. And that there's no evidence that supports the benefit to that. From children 2 to 5, they discourage passive, which would be like watching a video or watching a TV show or a series of some sort, or non-interactive use of it. Only 30 minutes per week during childcare. And this would be time at home with families or in the car. And this policy statement hasn't changed in when they first did, I think maybe 3 years. And so they really are watching this carefully. A lot of it has to do with brain development and what's stimulating to the brain. It's very addictive. And we don't want those neural pathways to get too deep in terms of watching that device. So again, just for your knowledge, to think about what Nacy and Fred Rogers recommend. So engineering is a way of doing. It's a way of using a variety of materials. It's creating, it's again, problem solving, building things. So you can see these little ones, you can just see on their face, their concentration, their focus on the materials as they build. Math is a way of measuring, sequencing, patterning, exploring shapes, volume, size. And I'm going to show you activities that are relevant to our younger ones in terms of math. So with infants and toddlers, I love this quote from Magna Gerber. It was like the Gerber babies, or is named after her, is to go slowly with great patience. We want our infant toddler classrooms to really be slow, quiet, peaceful places. We know we have little ones that cry easily, or they have trouble going down for naps. But we want it to be a place that the brain really can begin to take in information, experience things through gentle, slow pace. Again, we want that brain, and it's hard for me not to bring the brain into our discussions, but that's really slow patterning of the brain, so that your environment is slow, quiet, peaceful, lots of nature, which moves, generally speaking, in a slower pace. We want them to have lots of opportunity to explore at their own pace. Providing novel objects is very important in an infant toddler classroom, so that there's always something new to experience. For example, a basket of balls. You might have a basket of balls one week that's everything bounces, has lots of bounce to it. Another week you might have a basket of balls that are a variety of different sizes and textures. Another week you might have all balls that are smooth or bumpy. So that you're always bringing in new, novel things for children to explore. It could be one thing that you bring in and they explore. You put it aside for a month or two and then bring it back, because developmentally they have reached a new level and they'll explore it in a different way. So bringing in, one week you might bring a windsock in and they look at it and explore it. And then you hang it outside. And then when you're going outside, you can see what that windsock does in the wind. And all of that is STEM. It's all developmentally appropriate. It's teaching children concepts through their own, we would call it tacit knowledge. It's knowledge that is just sort of absorbed through their own body and experience, and then connected to verbal language, that receptive language that they're learning at this age as they're playing. Things that are high quality centers need to be, of course, developmentally appropriate, reflective and intentional. I always said when I would do observations that I should be able to walk into any of my classrooms that I oversaw and know exactly what you're teaching. We're working on this, we're working on that, that there's lots of planning, intentionality, but flexibility in terms of what the child is interested. So it's driven by the interests of the child, but the teacher is directing the learning along with them. That it's individually and culturally meaningful, it's inclusive of all children, that children have the freedom to explore. They can get messy, they can get things. There's not a rigidity of hardcore, we have to do it one way or the other, that they have the flexibility to explore and play through their environment. So I'll give you an example of this. Now, at Cal State Fullerton, they have a child development center that I was a mentor and a coach with. And a father came in who was a science teacher, and he wanted to do an experiment. And I had seen him do the experiment in the preschool classroom, and I was very impressed with what he did. He brought beakers and all things, and I was like, I can't believe he's bringing all this stuff you might see in a high school chemistry lab. But he brought it to the preschool children. And then he said, next I'm going to the toddler classroom. I'm like, okay, let's see what this is. So what he did is he brought a piece of red cabbage, which really is purple. It's not really red, it's kind of a reddish purple. And he chopped it up. He threw it in a blender with water, and then he poured a little bit of, in a clear cup for each child, this purple liquid, which was, it's non-toxic. And then he kept one, same purple, and then in another one, he put some, so they're looking at pH balance. And so then he added in one white vinegar, and it turned pink. He put another one in it with lemon juice, which is acidic. He turned it into, with lemon juice, that also turned pink. Then the fourth one, he turned and he put baking soda in it, and it turned blue, which means that it's more of a base. And the children were so, I couldn't believe the 2-year-olds were so intrigued with how just these simple ingredients that this man had presented changed colors. The only problem was that one little one who had started with the purple got kind of teary because she didn't want to give up her purple liquid, and then it turned into pink, and she was not happy about that. But other than that, it was a great example of that we underestimate what children can learn and what they can see. It's not that they understood pH balance, but that things can change. We can add things and it change. And it's just those early experiences that we want to help. We also know at this age that children are in that sensory motor stage. So everything kind of goes into their mouth. They see and sense the world through their hands, their mouth, their touch, their feel. And so we want to incorporate a lot of that sensory motor pieces, balls that are bumpy and are rough and smooth, and things that are soft and itchy. And we want to make sure that we're offering lots of sensory motor things. And we know that as children get older, they're always asking the question, why? What they're trying to do is make sense of the world and how to connect one learning to something new. And so this infant toddler cognitive domain is really important to think about when we're introducing STEM into our classroom. So we know about object permanence, mental representation, I'm going to talk about in a minute, cause and effect, memory, imagination is starting, spatial awareness, where do I fit? How does my body fit within this space? How to use my body, how to move my body. Beginning of mathematical awareness in terms of, example of this is that if when you're dressing a baby or helping a baby maybe put their socks and shoes on, you begin to introduce, you have 2 feet, we're going to put 1 sock on, here's number 2, we're going to put 1 shoe on, number 2, I'm going to give you 2 pieces of cheese, or I'm going to give you your sandwich or whatever it is, 1, 2, giving you, and you begin to, what we would talk about, mathicize your classroom. Your language is about using math. we have 3 children joining us now. We have 2 children playing here. You're using math, introducing math language throughout your day, connecting experiences and following directions. These are cognitive domains we're looking at. So imagine, if you will, for me, what a wind chime. So kind of, you can close your eyes and think about a wind chime. And everybody's wind chime is going to be different. Okay, so you may have the tubes that come down. They may be metal and really hard. They might be a little heavy. They might be cold. And then you have a clapper that clings in the middle that moves back and forth in the wind. So think if you can shift that metal wind chime into a bamboo wind chime. And how does that sound different to you? How would that feel in your hand? And so we begin to, as we're working with children, we begin to help them create these mental representations, these images in our brain, so that as we're learning about something new, we can connect them to. So you might have in your activities lots of things that are like the bamboo ones, things that are hollow, that don't weigh very much, that make a sound when they're tapped, versus the metal one that feels and sounds differently. So in your environment, outdoor environment, you may have a wind chime, or you might have a wind sock, that we're learning about the weight of them, the sound of them, how they move in the wind, how they create shadows. All of that is STEM, and it's all of that everyday STEM that we're looking at. But it also is the sound of it, so that children are creating those mental images. So it goes beyond like teaching the weather, which I don't find that that's like hugely helpful for young children. We want them to be able to identify, but we want them to experience it. So I don't think anyone ever taught you, well, this is a windy day. You probably learned much earlier on, when someone took you for a walk in a stroller, what that wind feels against your face, or what the wind, if you've had something and the wind blew it away, or what the wind does to a balloon in the sky. So we want to use a lot of language to teach these concepts of STEM. So as children get into preschool, into elementary school, they have these concepts already mapped in their mental representation. So a lot of that is teachers talking and working through those things. So your task really is to do that self-talk, asking questions. I wonder what this red paint feels like. I wonder if it feels wet. Does it feel sticky? What is this oobleck, or this clay that this child is playing? What's that feel like when you squeeze it between your fingers? So helping them make sense of what they're experiencing, giving them the language. Remember, this is receptive language for our little ones, that they're learning those language, and going slow. Just like Magna Gerber said, we're going slow with great patience. We're teaching slowly these concepts. So STEM fosters, again, those, similar to what I started out, those important critical thinking skills, problem solving, creativity, collaboration, and communication. Because you can see all of those with an example with these little ones. So science, when we think about science, typically people think about chemistry. I have to say, most people think about chemistry, but science is divided into scientific inquiry, those are the questions, physical science, life science, and earth science. So when you're saying, I'm going to do science with my little ones, think in terms of which of these science, physical science, life science, earth science, will you be doing? So I'm going to give you examples. So scientific inquiry looks at the process. And I wanted to show you this photo because these are 2 forms of technology, the age-appropriate technology. One is the magnifying glass, and one is the sand timer. And sand timers are appropriate to use in in something like this because they're watching that snail move. And so maybe they're tracking how long it is. Now, these are a little bit older children, but I want to make sure that you realize that technology is important during these early age, but it looks different than it does in elementary school and high school. So observation, because children observing, they take in so much information. So they are looking at that, and then we begin to document that. And I'm going to show you that too. So here, this is a child going in, pouring water into this, and there's a little wheel that goes around. That's a form of technology. This tool here that is to take the water in a baster is another form of technology. So these are some of the key words that you're going to be using in terms of being a teacher. Let's compare this ice cube to this liquid water. What do we see different? Is it one is cold, one is not cold, one is hard, one is, so you begin to use this language. We don't expect the children to be using this, but you use this language as you're interacting with the children. So these are all scientific and words, they're higher level words, but you will see those. I'm always surprised and amazed at how 3s, 4s can use these. I'm going to make a prediction. If teachers modeling that or caregivers modeling that, the children begin to use it. What's my prediction? And as a parent, you might encourage parents to use some of these. What do you predict will happen when we drop that ball? What do you think will happen for this or that? These are some good inquiry questions, open-ended questions. How will we measure that? I'm going to give you examples for all of these. So what do you observe? What I observe is da 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 da. I noticed that this pumpkin is orange and it's big, and again, you begin to incorporate that math, those vocabulary words into that. So physical science looks at the properties of non-living objects, such as solid and liquid materials, changes in objects and materials. So, for example, if you had a sponge or you had a water table with sponges in it. So what does the sponge feel like when it's dry? It's fairly firm. The texture, they might squeeze it, feel it. What happens when we put that sponge in a water table, and how does it change? And they can feel it. You talk about that. When they learn to squeeze it, they're using their hands, which is life science, and feeling how does it feel different? What's it feel like when we put that sponge on a piece of concrete or on a piece of paper? And then you can talk about what happens if the sun comes out and the water evaporates. You begin to incorporate your physical science with that. Anything that has motion, velocity, speed, throwing balls, creating an incline. This is an incline here. That is a form of technology. I'm not going to go into that piece on technology, but this incline here is a form of technology. So they're learning when they're throwing objects or racing cars with a ramp. They're learning about speed, velocity, density of the object. The surface of the object might be different. And then you could measure that. Again, all of that is STEM. Physical science looks at size, shape, weight, texture, and flexibility. So I give you an example of this because I've seen this in a classroom where a teacher was assessing to see if a child knew the word small, medium, and large. And she used pumpkins, and she had a small pumpkin, medium-sized, and a large pumpkin. And that was it. She was done. And I was like, oh gosh, she missed an opportunity there. So what I would have had her do is to ask the questions, why do you know that? How do you know that this one is small and which one is bigger? Which one is larger? And then I would have suggested, why don't we take either a measuring stick and measured it. Again, we're getting our math in there, and we're using our measuring stick or yardstick as a tool. piece of technology, measuring it. Let's put it on a scale. She could have brought a scale from home and weighed that. Which number is bigger? They're not going to know the numbers, but they're going to see that there's a difference in those figures that come up. Then I would have taken it just a little bit further, and I would have had some big thing of water, and I would ask her, do you think this really big pumpkin, or even the small pumpkin for that matter, will sink or float? What's your prediction? And then she could have taken that pumpkin and then something firm. It could have been a marble, and we know to be careful with things like that, or something solid that's small, which will sink because pumpkins will float. And that kind of is like, whoa, 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 if it's big, it must sink. So there's ways of just kind of very gently, in a very natural kind of, doesn't take much planning or thinking, is to think about how you incorporate other forms of STEM into your activities. And then I would chart that. Life science is really looking at living things and how they grow over time. Lots of people do things with, some programs have chickens, just had baby chickens, or they do silkworms. So it's looking at the properties of things. Our bodies definitely are part, can be part of this. And so looking at our body and how we use our body, physical characteristics that make us unique to ourselves and how they change over time. And earth science, really exploring the earth and materials, looking at light and shadow, which are great. So this is actually, I think this might be a new slide too. Things that are not easy to do, not expensive to have. A table with just some white paper and how the shadows, the sun moves through the day. You might plant something, do something outside where you see the shadow, you draw an outline of that shadow in the morning. Midday, you come back and draw it again. And so again, you incorporate these natural ways of adding STEM with light and shadow throughout the day. Characteristics of the earth, looking at soil, sand, rocks, water, air. Again, looking at where the moon is in the morning. Do we see it in the afternoon? Again, it's more than what's the weather today? It's sunny. Okay. What does that mean? And how do we incorporate something with a little bit more depth and thinking into our day? Technology. So these are examples of, here's a water table, which I love children outside in nature for so many reasons. It's just because it moves in a very slow pace. But these are tools. This shovel that this family child care provider is a tool, that's also a form of technology. Light tables are fantastic. An easy way. They're probably a little over $100 if you buy them, but they do last quite a while. But you can make a light table fairly easily by taking a clear, like a sweater container or a small container that's absolutely clear. Put a little bit of white paper in the bottom, and then just sparkle lights, those little clear ones, and that are battery. Put it inside and close the top, and you can get light, make a light table yourself. This example, I could do a whole lecture on this. And what this is a white wall, could be a sheet or just white paper. And you take a projector and you project onto the wall. And then on a table or somewhere next to it, you project what the children are building. Now they can build buildings, they can do engineer buildings, and they'll show up as on that wall, and you can put little people around it. It's really fun to see how creative children can be. You can have opaque things that are projected through that. I've seen it where they will take a computer that has on YouTube where it just looks like someone's driving down the road, and you so that's projected on the wall. So it looks like you're in a car driving down the road, but you put what would look like a little steering wheel for a child. It's just a ring of some sort. and they pretend they can sit in a box, or you can put pillows around them, and they can pretend to be driving down the road. There's some that are fish that you can project on the wall, and children can sit there and play with as if they're swimming with the dolphins or underwater with the fish. So thinking about how you use technology in that way is very effective tool and age appropriate. And it again helps with that creativity, that innovation, and they're facilitating it, but it's their imagination that's driving that. So looking at engineering and as children play, the building of things, the use of blocks. I'm a very big proponent of recycling materials. And so thinking about how children engineer and build things is really an important tool. And we want to be able to provide a variety of tools, things with small boxes. You can collect small boxes and have children build and engineer with it. So using your imagination along with theirs. I love this picture from a family childcare, and how they engineered this with water with just really mostly recyclable materials and things they had. Engineering, again, I said that it's not just, it's never, hardly ever just one thing. So here, this little boy here, I love how he's using his body to do this, and he's engineering, he's stacking these three, but he's engineering it, but he's also learning about physical science, because he's learning how to create balance there. He's learning how to create stability. And again, these are just like old coffee cans that they've wrapped in masking tape. Again, I mean, you can just see the concentration on his face again, and it's all right there, easy for him to do. But again, all of that is STEM. All of that is STEM. And documentation, these of course are for older children, but how you document and you use the tools that you have, forms of technology to document. Here's some ones that come from one of the college classrooms. Again, here's our magnifying glass. These are our technology. These are just picture frames where the glass has been removed, and they put two little eye bolts on either side with this little wire. Again, they have photographs of the children doing STEM, but a lovely representation of what your planning look like. You've got your text in there, some drawings from children. And again, documentation is important. Documenting over time, this would be life science. I'm looking at how the sweet potato changes, because it will start to root after a few days, and the children can look at that. Using art as a form of documentation. And again, it reinforces that child's learning, how they document. Now, it may be that you're doing that documentation for those really little ones, but as they get older, they're knowing that their work and their thinking is important, and we want that. So math is about classifying and categorizing objects. So thinking about how you might change up some of your areas in terms of ways in which children can sort and classify. It doesn't necessarily have to be in your dramatic play area, but you can think about how you change your dramatic play area. I'm one of those that thinks they need to be changed every month or so, not just the same things, because as I said early on, children love and need novelty. But thinking about how they classify, but we want it to be of course, play-based. Helping when children help with, which I know can get kind of messy, but these little ones, you can see that they're really focused on that pouring, again, that science, that physical development that's going on there. Looking down, estimating, they're estimating. They don't know that they're estimating, but they're making an estimate of how it's, say, half full. Again, we would then do some counting, and then again, reinforcing those other concepts of math inside there. These I know are objects that are not safe for our birth to 3, but I wanted to just give you examples of how this might look in an older classroom, in terms of classifying and sorting, making patterns. You might be able to do this with some larger objects, but again, I know some of you may have mixed age group children, so I wanted to incorporate a little bit of what it might look like in an older classroom. Again, same objects are too small for little ones, but again, counting and sorting. Matching colors, again, we're getting different cognitive concepts in there. I wanted to introduce this concept to you, which is a preschool TK kind of concept. It's called Subitizing, and it's a math concept. And what Subitizing is, again, for a little bit older children, is their ability to say, look at numbers without having to count them. And what that means is if I know how to Subitize, I can look at this die and know immediately that's a 6. I didn't need to count 1, 2, 3, 4, 5, 6. I can look at these 3 dots here and know that's 3. I can look at this and know it's 2. I don't need to count each one. And that's a cognitive development piece for understanding math, is that they learn to subitize, so that when they're in elementary school and they get to say 2 plus 2, they can look at these 2 and these 2 and they can add them. So it's that sort of more advanced math concept. But again, we want to be able to start that early math language, that understanding. Let's get 2 shoes, and they can see 2 shoes, 2 socks. And so you begin to sort of build those concepts of subitizing. So looking at how we inquire, I love the idea of magnifying glasses. Hope you will know by now that this is a piece of technology, but as children are curious, they want to learn about things. So we want to think about having activities both inside and out, which I've mentioned, that you really are guiding that instruction, but it is child-directed in many, many ways. Children have opportunities to freely investigate, discover the materials on their own. I wanted to say too, is that my recommendation, if a child is building something or engineering, or you decide that as a classroom you're going to build something or transform your classroom into, say, a different kind of space, say an aquarium, you want to build an aquarium of some sort, you're going to use that technology that I mentioned with the undersea exploration, that you leave that you leave time. We sometimes we recommend it, we do a sign that says still under construction, that if children are building things, that they have the opportunity to leave those things up for a day or two if they're still building on it. If they go, and that's a question, are you still working on this? Yes. Or maybe they're no. If it's yes, would you like to leave it till and finish it or work on it again tomorrow? Yes or no. And so you leave them opportunities, because if we say, oh, you only have 15 minutes, you have 10 minutes to create, that really limits their ability to really create, come back and explore. And I always think that if it was me and I was working on, say I was doing a craft of some sort, and I only had a certain amount of time, I'd be kind of frustrated with that. And I'm like, no, I really need to, like, can I stop here and come back to it tomorrow? And so I want to really encourage you to let children have opportunities to leave things up another day or two, so they can go back and continue working on that. I talked about the teachers modeling, scaffolding the learning, and asking those inquiry questions, and then the documentation. So I'm going to go through. These are just really quick slides for you. Physical science and body awareness. So certainly a slide, which is an incline, which is a form of technology. They learn about speed, velocity, surface tension. If one child's pants are kind of slippery fabric and someone else is kind of rough like a denim, they may go faster. If someone weighs a little bit more, weighs a little bit less, they're going to go faster or slower. If they have their shoes on, the shoes off. This comes from another school, Orange Coast College. And they have a amazing STEM program where children go barefooted all day in this amazing area, and they have animals and they have garden, and it's like a magic place to me. These little ones, same preschool childcare. I'm looking at they'll be mixing colors. They're not probably aware that they're mixing colors, but they are. Their paintbrushes are their tools, but they're freely exploring. They're free to get messy. They might taste, because of that sensory motor piece, they may be tasting some of that non-toxic paint. Rocks, again, this is for older ones, but you certainly, if you're supervising, you can look at you can bring a rock in where you're looking at what's it like when it gets wet, how does it change? But looking at how you might use those. And again, close supervision, certainly for our little ones and for our preschool children as well. But to notice how you might use some of those earth science, life science pieces. This again is that same school where this teacher, who's amazing, has created these water play over grass. She's very conscious of water safety and water use. She moves it, she rotates it, so things are always getting wet, things are not getting, water's not being misused. It's not, this is how she waters her garden. Sink and float, which I love to think about sink and float. They've tied in the words here, which our little ones aren't aware of, but they're beginning to understand about letters and sounds. But they can make these predictions. Excuse me. I like to think about how you use water in a variety of different forms. So I think I have a picture next. Yeah. So in here, they had water frozen in here, and so it's beginning to melt. So they talked about the properties of water. And again, that's physical science and it's earth science. And then what it feels like as it melts. I have an example in my book about taking a latex glove and filling it with certain objects that might sink and float. So you might, just a variety of things. And then you fill it up with water. So it actually looks like a hand, and you tie it really tight at the bottom and you freeze it. And then they put it in the water, and then you take the latex off, and then it begins to melt. But inside it are things that sink and float. And so we're kind of tying a variety of different STEM principles into that. You might think about how then that water's frozen into a liquid. You might then have an activity where they take some of that water and they put it in the garden, or you might take some of that water and they do some painting with it and think about evaporation and what happens with that. So you, again, sort of that planning, using your imagination to think about the different forms of water and how you use it. Again, using our water wisely and efficiently. Water absorption is another easy water piece. Again, you're putting this, you put these dots, these are just with our markers. You take a picture of that, and then the children you might say how much time do they predict it'll take before it changes or not change. You do some estimations, you come back and you look at what happened. And then here's another way to do it with the different colors and how this takes time. What happens over time, eventually, if we wait like overnight with this, all three colors will be the same because they will all absorb equally. And so that's kind of another easy water absorption activity that you can document, and it's easy. With plants or flowers, using oobleck, which most of you are probably familiar with. And again, it's you understand the properties of that, and the sensory motor piece of that is always a fun, messy activity to do with little ones. So more of that sensory activity. When I asked participants, one of the earliest STEM activities that they remember, lots and lots of folks will say playing in the mud, building mud pies, building things with mud. And so think about, is there an opportunity for you to do some of those things with your children? Again, making sure they've got an extra share of clothes. There's a few preschools that I know that have mud rooms, which is kind of a luxury to have. But again, letting children feel, touch, explore, things like that. Providing different sensory experiences is also part of STEM, and things that are smooth and rough and bumpy and textured, so that they have the words and those mental representations that we want them to develop through STEM. Looking at how we might incorporate STEM and music. With a drum, children can put their hands on that drum and feel the vibration, part of STEM. Hitting it, the motion of that, the velocity. Again, those aren't words that they know, but it's the concept, it's those mental concepts that we're wanting them to develop. Understanding about the body and how they move their body, how you might do songs and movement around the body. Really good for self-regulation of using the body. But again, you've got STEM incorporated into that. If you have the luxury of having a garden, is a really great opportunity for children to learn that life science and earth science. Always adding something living in your classroom that children can watch and monitor and look at how they change over time. This leaf activity here is just a piece of masking tape that you put the sticky side on. And as the children go for a walk, they're collecting leaves that have fallen to the ground and make a leaf bracelet with that. Here is this lovely family childcare where she's gardening with the children and they're learning about planting. I'm very much into recycling material. I'm like a really oh, I can use that for something else. But looking how you can look at this is how easy this is. Cardboard is like amazing, but taking this big box, and these are tubes from like wrapping paper, and you have to make sure that the balls or whatever you're using are the right size. But having the children help you figure out where they want those and how they're used. Big tubing. Anytime I see this stuff, I'm always grabbing it. But excuse me, thinking about how you would do this with 2 or 3 children is they might each have, say, a matchbox car. And so you would have one do it, and then you mark with marking paper and measure it using the tape measure, how many inches that was. And that was the red car. Then the green car comes down. And usually they're not the same. And sometimes one goes really a long distance. And so your tying math into that in a play-based activity. Again, look at this simple tubing. They're learning about gravity. They're learning about cause and effect. You might be standing near them, counting with them, or saying what color the ball is that's going down there. These are just PVC pipes that people can get at Home Depot or Lowe's. And again, they're learning about physical development. They're learning about engineering. Again, simple, easy, not too expensive. Light tables are another object. Just using repurposing our bottles here, using there's lots of things. Are things clear? Are they opaque? What happens here? What happens? Flashlights are another tool that you can use for light. These are just popsicle sticks with acrylic with different things in them, and children can put those over a light table. Using these are magnet wands that I got from Lakeshore. These are pipe cleaners that have metal in them. You can use a variety of different things in here. These are paper clips. Seal it really tight so the little ones can get into it. But again, it's a fun kind of nice calming activity. Thinking about how you might create your own kind of wind chime using a variety of different weights of materials. This is not a cast iron skillet. This is a very light skillet. You would never put something that's really that heavy, but these are all really small. And they kind of clang again. It's sort of that cause and effect that we want our little ones to have. Certainly mixing, which is like looking at materials over time, going from a liquid to a solid. If you're like making muffins or say banana bread or something, measuring, you've got math in there. Weight, again, predicting, estimating. And it's your language, but as a preschool teacher, you might be doing that. Mixing colors, tying literature. There's lots of great literature books that are in there that bring in math. STEM is everywhere. And it's a great time for children to cultivate their math skills. Here are my 4 books that I've written, and my email. And I think our time is up. Thank you, everybody. I appreciate everybody hung in there with me. I appreciate it. I hope you came away with lots of ideas. My books are on Amazon and through Red Leaf Press. And if you would like more information, or I'm more than happy to respond to an email. It's at the top. And I appreciate everybody coming and thank you very much. I know I went fast, but I hope you came away with new information. So thank you, everybody. Have a great rest of your conference.